What's up, snowmobiles? Rascal. Hey, hey. Snowmo, what are you up to these days in life? I just went ahead and started the event, so people should be notified in Discord. Oh, let me make a float really quick. Oh, wow, I'm so glad I just remembered that. I gotta make a float. Otherwise, everyone would have flamed me. Nothing too exciting, yeah. Wow, everyone's being everyone's being very conservative about what's going on in their lives. I asked Sweet what was going on, and she said it's going. And then I said it's going. And now you're saying nothing's happening in your life. So and no one's doing anything. Nice, guys. Um,
Did you
what's up, Shiver?
did you get in on Dimension X?
Yo, what's up, Franken?
Hey buddy, how you doing?
Good, how are you?
Good man. Did you get in on Dimension X?
What is that?
The game on Flow.
Oh, no, I didn't.
It's like have you not heard about it?
No, I haven't heard about it. What is it? Share.
Uh, yeah, like play to earn. I'll just quickly chuck it in chat.
Yeah, throw it
It's
in
huge.
there.
They managed to mint out. It was a free mint. Um, but they've been pushing hard. They've got a partnership with Flow as well, I'm assuming, because Flow had them on a Twitter space yesterday.
Interesting. I had no idea what they are. Does anyone else know what they are? Sweet. I feel like you would have heard of it, right? Yo, what's up, Engayo? Good to see you here. You want to see mine? Oh, yeah, Franken. It looks like Sweet knows what this is. Wow, I am very curious to see this now. Hold on. Let me set a claim limit on this thing. Let me use a secret code. Secret code's gonna be Town Hall 1. Oh no, why Town Hall? No, Workshop 1. Workshop 1 and everything good. September 1. Sorry, I'm just setting up a float right now for all you that are tuning in right now. All right, go ahead and create that float. So, oh yes, Franken, I did see these on Twitter. But what can you, if you don't mind, Franken, what can you do with
Yeah,
these?
it's just idle play. Then you level them up, and you can actually get tokens to then mint other NFTs as well.
Ooh,
So it's a bunch of like strategy based because if you go in certain battles, you've got certain level ups and certain multipliers as well. So you want to use certain monsters, whatever they're called, on certain level ups and in certain battles.
that's pretty cool. I'm checking out the website here. Let me go ahead and actually share my screen really quick, and then we'll get started with the Academy right after. But I'm sharing it on my screen right now for anyone that doesn't know. Dimension X, this is pretty cool. Well, I'm not gonna log in, but I don't want anyone to see my stuff. But yeah, that's pretty cool. I'll definitely check that out after. Thanks for sharing. Snowmobiles finished watching Steins Gate. Nice. BZ has been telling me to watch that. I really want to watch that. What's up, Skyman? Hey, Generous Kid. I see a lot of people returning for another Academy session, so welcome everybody. I see Amethyst here, one of our instructors. Hey, Amethyst. Hope you're having a good week. Andrew Fowl, what's up? Christina, hello. Crypto Chica, thanks for tuning in. Griet, what's up? What's up? Numini, hey. Saint Da, what's up? I think that's everybody. All right, so we got a few people here. Some of you are returning from previous boot camps. So yeah, I'm just gonna go over, what we're gonna talk about today, and yeah, I think we'll just get started. So today we're meeting for the first workshop of our September boot camp. We have done this boot camp, pretty much every single month for the past 5 months. And for those of you that came to our introductory session on Monday, you already pretty much have a grasp of what this academy is going to be like. But we're inside of our introduction to Cadence course, and so we're going to start actually with our repo. We're going to open up our repo right here, and you're pretty much just going to it's going to be a bit of a boring day only because there's a lot of like written content. And the instructors know especially that I hate written stuff. I find reading very boring. In fact, I can barely read. But we're going to do it. We're going to start with chapter 1, and we're just going to dive right into it. So, again, it's going to be a little boring at first, but I promise that by the second half of this workshop, we're actually going to dive into some code, and that's when things should get a little more exciting for all of you. Okay, so let's just start out with chapter 1. We're going to talk a little bit about what the blockchain is and what Cadence is, which is the smart contract language that we're going to be learning during this course. And then after having sort of a general understanding of that, we're going to go into some code, like I was just saying. So, if you have any questions at all during this session, whether it be on the content I'm covering, or maybe you had a question on the quiz that you maybe have done so far. If you haven't done any of the quizzes or quests, don't worry at all, totally fine. Or if you have any questions on the quests, like feel free to answer or feel free to ask, and me or the instructors will be here to answer. So, without further ado, let's get started on chapter 1, day 1. So, one of the first things we want to talk about is what actually is a blockchain, right? Why are we here learning about Cadence? All this stuff is a little bit confusing, but, let's actually understand the infrastructure behind, the smart contract language we're learning, so that we know what we're doing here, right? So, what the heck is a blockchain? Well, a blockchain is, in very simple terms, it's an open decentralized database, or open decentralized public database. So these four terms are really what describe what the blockchain is. Open meaning that anyone can interact with it. There's no restrictions. There's no one telling you that you can't interact with it, but you can, right? Everyone can interact with it. It's decentralized in the sense that nobody really owns it. There's no central authority dictating stuff. Now, usually we get some questions about this because some people say well, isn't Flow kind of centralized? And the truth is that yes, I'm going to be the first one, I'm going to fully admit that Flow is a bit centralized in the sense that if Flow woke up tomorrow and decided to shut it all down, obviously it would plummet, right? But in an ideal sense, a blockchain is supposed to be decentralized in that no one truly owns it. Um, and this is not similar to things like Google or Amazon, where they are completely centralized companies, right? Where if Google woke up one day and said, you know what, screw it, they could completely take away the Google search engine, or they could get rid of all the data in their database, or Amazon could just stop delivering to you, right? These are not, similar to the blockchain where it should be decentralized in nature. It's also a database. This means that you can store things in it. So what we're going to learn is that you can actually store quite a bit of information inside a smart contract. One example of this is like information about your NFTs or how much flow token you have. Right. This is information that exists on the blockchain, more specifically inside of a smart contract. But we're going to learn that later. So it's a database, right? It can store data, and we can even read data from the blockchain. That's also important that we can write and read from the blockchain. And it's public. So this is very similar to open, but public means that anyone can view the data on it. So I put this here because I just want to make it clear that everything is public on the blockchain. No matter what we learned in this course, you should always be aware that every single thing on the blockchain is public, right? Who you transfer tokens to, anyone can see that. How much tokens you receive from an employee or employer, anyone can see that. If you put a secret password on the blockchain, anyone can see that. If you put your email on the blockchain, anyone can see that. So nothing is private on the blockchain. And of course, you can do some fancy things like encryption, which is where you basically turn information into a series of like numbers and letters. But even that is not entirely safe because someone could eventually, attempt to decrypt that information. So those are the four, aspects of the blockchain. Now, now that we know a little bit about what the blockchain is, right? The blockchain is basically this thing that's out there, right? With these four characteristics, but we're going to be learning about smart contracts much more in depth. So what are smart contracts? Well, smart contracts are basically ways that we interact with the blockchain. They're basically it's hard to put it in other terms, but they're basically contracts or like rule books, you can think of them, that exist on the blockchain that dictate what can happen to the blockchain and what information we want to store. So what I mean by this is you can have a smart contract that stores data. You could have a smart contract that mints NFTs. You can have a smart contract that creates your own tokens, right? These are all things that are characteristics of a smart contract. And I think that, right now it's probably a little bit confusing as to what this actually looks like. But don't worry, we're going to spend pretty much this entire boot camp coding smart contracts. So you're going to get a much better understanding of what this actually is. Um, I guess the important things to know about it is, these things right here, right? What are the upsides to smart contracts and why do we use them? Well, they're really fast, they're really efficient, and they're accurate. So what I mean by accurate is, with smart contracts, you are coding them, right? Or someone codes a smart contract. And when you code a smart contract, right, you put that out there on the blockchain and that then dictates what happens. So when you code something in a smart contract, it is very accurate in the sense that it'll do exactly what you tell it to do. So, people often debate the term smart contract because in reality, contracts are, actually really stupid, which is sort of like against the name, but they're actually really stupid. And the reason for that is because they don't know what they don't know what to do. They just do what you tell it. So in nature, they're actually quite stupid. It's just that they exactly follow what you tell them to do. And this is similar of all code. If you're a developer, it's pretty similar to that, in that if you write code, it'll execute that code and nothing more, nothing less. Um, but this can also be bad in the sense that if someone writes malicious code or code that does something bad, like steals all your tokens, the smart contract will do that, right? So it's really up to the developer to see what's going on, or to make something happen. And another characteristics of smart contracts is that they're very trustful and transparent. So if you look at a piece of code and someone tells you, hey, you should mint this NFT, you can actually go ahead and look at the smart contract and see exactly what the contract is doing. And if you understand the language, which you will after this bootcamp, you'll be able to see, you'll be able to look at code and trust that what it's doing is what you think it's supposed to be doing, and transparent in the sense that you can always see what's happening on the blockchain. So if someone sends you tokens, anyone can go to the blockchain and look at that and see that it went through a certain smart contract. Now, some downsides are, they're really hard to get right. So, again, smart contracts do exactly what you tell them to do. But if you don't do it perfectly, it won't do it perfectly, right? Because it's following what you said. So, you need to be a smart developer in order to actually write smart contracts the way they need to be written. And you don't want to leave a bug or a mistake in your code because then someone could exploit that. And we see that happening all the time in the Ethereum space, where you look on Twitter and you see $8 million stolen out of liquidity provider, and that's because someone forgot one line of code in a smart contract, right? So you really want to be careful about who you're trusting and who's coding these contracts, and that's part of why smart contract development is so expensive. Again, it can be malicious if the developer is mean. We talked about that. And another thing with smart contracts is really you can't undo something. So if you accidentally send someone 100 tokens, you will never get those back unless they send them back to you. Or if you accidentally, allow anyone to mint your NFT without paying for it for some reason in the code, then you can't undo that, right? It's there forever. We're going to talk a little bit more about this and some characteristics of upgradability and changing smart contracts. But for the most part, in the broader blockchain world, when you think about Solana or Ethereum and sometimes Flow, even, smart contracts are hard to change. So that's one thing to keep in mind as well. So this brings us to sort of like the one of the last main topics of this day. And again, we're almost done with the reading part, is transactions and scripts. Well, what are these? We're going to be coding these a lot during the bootcamp, but right now I just want you to have a conceptual understanding of what they are. So transactions are basically ways to change data on the blockchain, and scripts are a way of reading data from the blockchain or viewing. So a transaction, I'll give you an example of a transaction. Actually, I'll ask some of you in that are listening right now, when I say a transaction changes data or does something on the blockchain, right? It alters its state, and a script purely reads information from the blockchain. I'll ask you this: if I go ahead and mint an NFT, do you think that's a transaction, or do you think that's a script? You can type your answer in the workshop channel, and we'll see what people think. Seems like people might be stumped. Are people confused? Do you want me to ask? Do you want me to try again? I think Gria might have an answer. And don't be afraid at all to get it wrong, by the way. It's totally okay just to guess. So I guess I'll try one more time. So if there's transactions and scripts, right? A transaction is something that changes data or actually performs an action on the blockchain. Like could be anything, right? Like changing some sort of data where like you're transferring an NFT to someone, right? And you're changing who owns that NFT, or you're purchasing tokens, right? That changes the balance of someone's account. Whereas a script is just reading data from the blockchain or viewing it. So if I were to mint to you an NFT, or you were to mint an NFT, do you think that would be a transaction or a script? Yeah, exactly. Exactly, exactly. Good job, guys. Yeah, so it's a transaction. Because you're changing what you're doing is when someone mints an NFT, you're telling the smart contract that that person now owns that NFT, right? So you're actually changing the data on the blockchain. And forever now, the blockchain knows that that person was the one that minted it, right? So you're changing the data on the blockchain. So exactly, it's a transaction. Whereas on the other hand, if I were to ask you, if I'm viewing the metadata of an NFT, or if I'm viewing how many NFTs you have, is that a transaction or a script? Well, obviously it's a script because we're viewing information about the chain. Um, Now, one thing to note about the difference between these two is that a transaction actually costs money, or more specifically, it costs something called gas, whereas a script is completely free. So it doesn't cost any money to view from the blockchain or to call a script, but it does cost money, or people call it gas, to call a transaction and change the data. And the reason for that is because when you run a transaction, a bunch of computers that are running the blockchain across the world, right? They're called nodes. These are things that are actually making the blockchain run and verifying the information on the chain. Those computers need some sort of payment in order to keep verifying the chain, right? There needs to be an incentive for people to, verify the data and keep the blockchain running, right? Those nodes. And so that's why there's gas when you run a transaction, because you need to pay those people. Now, on Flow, if you don't know already, on Flow the gas is actually extremely low, whereas on chains like Ethereum, it could be even $100 sometimes, or potentially way more. Exactly, great. Yep, it was a transaction. Exactly. So one of the things I also want to talk about before we dive into some code is the difference between mainnet and testnet. So this is something that definitely gets confused and is like, sort of technical terminology that people don't quite understand. But there's a difference between mainnet and testnet. So on testnet, you can almost think of it like a playground. This is where developers test things, right? They make sure things are working. They test their applications. They try and find bugs in their code. It's a test framework. So everything on testnet is fake. There's no actual money involved. Transaction costs fake, money, and it's a good way for developers to test their smart contracts. So what they will do is, developers will write smart contracts and transactions and scripts and test them on the test net. And then when they're ready, and they actually wanted to, put these out there to the world, they'll put them on mainnet. And that's when everything is real. You can actually do the things you want to do. Money's involved, transaction costs, actual gas, and your application is out there for anyone to use. So that's the difference between testnet and mainnet, and we're going to talk more about that at the later in the course. But just so that if you ever see these on Twitter, or if it's random, you don't know the difference between them, that's what this is right here. Um, and then, lastly, I think this is the last thing in this chapter is, what is a DApp? Well, a DApp stands for decentralized applications. This basically is, it's actually extremely simple. It's literally just normal applications. So think about like Google or Amazon, or literally any website you interact with, except you add the word decentralized to it. And that means that it includes like blockchain stuff. So whenever you see DApp, just know that that means any normal application that also deals with smart contracts. That's pretty much all it is. All right. So that is the end of day one, or chapter one, day one. We're going to go over chapter one, day two, which is actually much shorter. You can see it's actually super short. And this talks a little bit about the Flow blockchain specifically, and comparing it to other chains like Ethereum. And then we're going to dive into some code. So before I move on, does anyone have any questions about what we just covered? And if you do, again, don't be afraid to unmute your mic or type in the chat. We're here to answer. So I'll pause for like 30 seconds or so, and if no one has any questions, we'll go into this part. I'm definitely excited to get into some coding. Yeah, what's up, Raven? Hey, Boom. I love how you kept your name. Oh, how cute, Calcoin. That you here too, joining. All right, cool. It seems like no one has any questions about that. Great. And if you ever do, you can always ask in the chat channel as well. All right, so we're going to talk about why we're learning about the Flow blockchain as opposed to other chains. So, here it is. The Flow blockchain is the best. Boom, I said it. That should be enough to convince you already. But if it doesn't, we can move into some, very quick facts about Flow. So, it's just a super, super short history lesson. Flow is a blockchain that was founded by Dapper Labs. Dapper Labs is the company that owns Flow. They originally created, one of the most famous dApps called CryptoKitties. That was like one of the earliest dApps that ever existed in the blockchain industry. And they saw massive success with that. But, one day CryptoKitties had so much attention that it actually crashed the Ethereum blockchain. And so Dapper Labs decided to make their own blockchain called Flow, and that's where we are today. So we're learning about an independent chain. It is completely separate from Ethereum. Some people ask, like, is Flow a layer two? Is it built on the EVM, which is the Ethereum virtual machine? The answer is no. Flow is completely independent from Ethereum. So yeah, that's where we are right now. So some facts about Flow. Number one, it's much cheaper than Ethereum to do stuff on. Gas is a lot lower on Flow. So on Ethereum, when you mint an NFT or you transfer an NFT or you do any action, you have to pay a pretty significant gas fee, right? That can be, from $5 to $20 to $80 to sometimes I've seen it even be $400 just to perform an action. Whereas on Flow, it's like fractions of a cent. So that's, number one. Number two, it's still pretty new. Actually, when I originally wrote this course, it was relatively new. I'd say it's still new, but it's getting to a point where it's sort of like the foundational elements are there. There's still bugs here and there, and things are still definitely changing, but it is still relatively new, especially compared to Ethereum. There's barely any learning resources, hence why we're here. So if you're currently learning this course, you're actually, even though we've been running this course for like 6 months, you're still one of the first people to like learn about cadence, right? There's literally very, very few people that know cadence, so it's great that you're learning it now. Because I imagine in a couple years, this language will be, I think as common as Solidity, which is the one for Ethereum. So good for you for taking the step now. And also, there have been many successful dApps on Flow, like NBA Top Shot, right? If you didn't know already, NBA Top Shot was built on the Flow blockchain, and actually is all, the smart contracts are all written in Cadence. So towards the later end of this course, we're actually going to learn more about how NBA Top Shot was built, so that you can go ahead and maybe make your own contracts too. So is there any possibility of the gas increasing with that of ETH? So I think like it always is possible. I think it's definitely not possible that it gets anywhere where Ethereum is right now. I mean, like there's a chance it could become a few dollars, like maybe if the chain gets super, popular. But one of the reasons why it's actually cheaper is because Flow is a proof of stake protocol, which is different from Ethereum, which is proof of work. Now, proof of work is known to be a lot more expensive. And that's why Ethereum is actually, this is sort of unrelated to this course, but Ethereum is actually merging into ETH 2.0, which is going to be a proof of stake protocol. So it's going to be similar to Flow in that the gas is definitely going to decrease. I mean, at least people hope, right? So at least for the foreseeable future, no, it won't increase to Ethereum levels. but there's a chance it could definitely go up in the future. I just, it's hard to tell what that number would be, but nowhere significant in my opinion. Cool. And then the last thing in this day before we jump into some coding is cadence. So, cadence is the smart contract language for the Flow blockchain. It's what the computer language is called that, we write smart contracts in for Flow. Currently, Flow blockchain is the only blockchain that uses cadence as its smart contract language. So it's unique in that sense. And, cadence has some pretty interesting, like characteristics about it that differentiate it very significantly from other smart contract languages. One of them that we always talk about is clarity, approachability, and developer experience, or I should say three of them is these three right here. Now, coming from someone who has coded a lot in both Solidity and Cadence, I can promise you, and I'm not just guessing here, I can promise you that Cadence is a lot easier to learn. It's a lot easier to read, and it has a much better developer experience. I've heard the term that like, Cadence makes it very hard to footgun yourself, meaning it's very hard in Cadence to mess up. Whereas in Solidity, it's very easy to mess up. And in fact, that's why we see so many hacks in the Ethereum space, is because, any Solidity developer could leave out one line of code, and that could lead to multi hundreds of millions of dollars of leaks. Whereas in Cadence, the smart contract language would tell you that you're messing up ahead of time. And the way that it's structured makes it really difficult for the developer to leave that sort of leak. And if they did, it would be, pretty obvious. So that's a really good feature. Now, and that also leads to safety and security, but we're going to talk about this more later. And I think the other really important point to note here that we're going to spend most of our time talking about this one actually is that, Cadence is what we call a resource-oriented programming language. What this means is, when you think about an NFT, right? An NFT is an asset. It's an object that exists on the blockchain. Well, this isn't the case actually in the Ethereum world. In the Ethereum world, the way that NFTs are actually made is they're literally just a number in the contract. And actually, maybe what I can do is let me pull up a little spreadsheet here and show you guys what I mean by this. So why is that so small? Okay, this is interesting. I'll try and work with what I have here. um, but in Ethereum, so let me just put like ETH here. So this is the Ethereum world. How NFTs are represented is you have a smart contract. Now, picture a smart contract like a rule book, right? Like there's a bunch of rules in here. What happens in Ethereum is you have like, a person right here, and this person owns an NFT, right? Well, let's say they own NFT number one. In the Ethereum world, the smart contract says, okay, NFT number one is owned by this person, and NFT number two is owned by this person, right? It's literally just a mapping of number to person, like this. Whereas in the Flow world, it's actually very different. It's very different. What happens is they don't exist in the contract. What happens is each user has an account, like a little box. So each user has its own little box. And inside their box, right, you can almost think of this as like their, I don't know, like their backpack. They actually have assets in their backpack that they hold on to. So each of these is an NFT. So it's very different in the sense that in the Flow world, NFTs are actually assets. They're objects that the user holds on to. Whereas in the Ethereum world, it's just a number that maps to a certain user. So an NFT doesn't even really exist in Ethereum. It's just a number. So that's an important thing to note here, and this is what we talk about when we say resource-oriented programming, is because on Flow, assets are actually represented as literal objects that we give to users instead of them just being a simple mapping in a rulebook somewhere. So I hope that made sense, and if you have any questions about this, you can let me know. But this is really important to understand. Maybe my drawing isn't the best. In fact, it's pretty terrible. We can all admit. But this is a pretty important distinction to make between these two chains and why Flow was actually designed for NFTs. When Dapper Labs created Flow, their primary use case was NFTs. So that's a big difference. All right. So that's all the talking I'm going to do. That's probably the most amount of talking I'm ever going to do. Thank God, honestly. I feel like am terrible at reading. But does anyone have any questions on chapter 1? We already finished chapter 1 because it just has 2 days in it. Um, so I'll pause for 30 seconds to a minute and see if anyone has any questions about chapter 1. And then if not, we're gonna dive into some code now, which I think is a lot more exciting. How's everyone doing? All right. I'm gonna put a little thumbs up in the chat, and if you're doing good, you can thumbs that up, and if you're doing bad, you can thumbs that down. Just so I can get a view of what everyone's thinking. Don't be afraid to thumbs that down if you're struggling. We've all been there at some point. But it seems like everyone's doing all right. All right, we got 10 thumbs up. Nice, everybody. We got a thumbs down from Boom. Boom. You struggling, Boom? Have you forgot all your skills? Honestly, good. I was starting to catch. You were starting to catch up to me, Boom. All right, cool. All right, let's move into some coding. It seems like everyone's doing all right. So before we actually dive into some code, I just want to mention really quick that like it's totally okay if none of this makes sense to you, especially for those of you that have never coded before. It's gonna be like I'm not gonna lie to you, it's gonna be really weird to look at code for the first time because sometimes in order to code or in order to start coding, you have to develop like a developer mindset first or like a coding mindset, and that takes time. So, if you've never coded before, I would definitely recommend checking out Chapter 1.5. This is specifically designed to help you learn about coding. But with that being said, it's still okay to struggle through this. All right, so let's struggle through this together. So, what I have loaded up here is a Flow playground. Um, yeah, so I've loaded up a Flow playground here, right? And so this playground is basically a way for us to interact with like the blockchain. Now, there's a quick note, one thing I want to note here is that everything that we do in this playground is fake. Okay, so when we deploy a contract or we mint NFTs, it's all fake in the playground. So none of this is real. And in fact, it's only real for you. So when I do stuff here, you're not going to be able to interact with this. And that's because this is all happening on something called a local emulator. So remember we talked about testnet and mainnet? Well, emulator is even before testnet. It's like the pre-testing phase. So that's where we are right now. Okay, so nothing is real. So let's go ahead and actually make our own contract. So again, don't worry about the coding yet. Just understand this conceptually, okay? So I'm going to go ahead and make a contract called Hello World, right? If you haven't coded, basically Hello World is like the default example like everyone uses in every language. But I just made a contract, right? So it was that easy. I just made a contract. I said public contract, and I named our contract Hello World, and I opened up 2 curly brackets here. So this contract, right? Boom, we just made it. We just coded it, but it doesn't do anything. In fact, we could deploy this, right? You see this deploy button right here? This means, okay, we're done. We want to actually put this on our fake blockchain. Let's deploy it. And it says, okay, deployed contract to OXO1. We're going to talk about what this means in a second. But we just deployed our contract. Now, that's cool, but it doesn't do anything, so it's not useful at all. Remember that smart contracts, they do exactly as we say. So, if we're not saying anything, the contract isn't going to know what to do. Okay, so it doesn't know what to do. Now, what did this mean? It deployed the contract to OXO1. Well, this is what we call an address on the Flow blockchain. So, or really, like you'll see this on any blockchain, but addresses sometimes look different. On Flow, this is what we call an address. So you'll see on the left-hand side here, there's actually a lot of different addresses. There's OXO1, OXO2, OXO3, right? These are all addresses, but they're fake. So in the real blockchain world, addresses don't look like this. What they look like is something like this. I'll paste it right here. They look like this. right? A long series of numbers and letters. This is a real one, but because we're in a test environment, it's shorter just to help us out. So just keep that in mind. Now, the what addresses are is they're really like your identity. Addresses are tied to an account. So, like we were talking about here, you see how we had a person here that had a backpack, and inside the backpack they have 4 NFTs. Well, this right here is your account. This backpack, right? This is your account. And each account has an address associated with it. So that's OXO1. This is OXO2. You get the point, right? So each account or each wallet has its own address. All right. So when we deploy this contract, you actually deploy contracts to an account. So that's just how it works in the Flow blockchain world. Is when you want to put a contract out there, you actually deploy it or put it out there to a certain account. All right, so that's some basic information about contracts and addresses. So any initial questions about that? I'm going to pause for like 10 to 20 seconds. Any questions about addresses or accounts or stuff like that? And I guess just to further clarify, like if we wanted to, we can make a contract and account too called Goodbye World, and we could deploy this to account two. So now account two has a contract named Goodbye World in its account, right? But that's totally separate from account one. Okay, we all good? Nice. I'm just gonna assume we're all good. So again, don't worry about the coding, but I'm gonna do something else here. What I'm gonna do is I'm gonna actually store a piece of information in this contract. So what's gonna happen is I'm gonna type this out. Again, I'll explain the coding in a second. What I just did is I made something called a variable. Now, in coding, a variable is something that stores data. So this variable is called a greeting. I just called it a greeting. Now, this greeting is going to store something inside of it. Now, in Cadence, Cadence is really strict in the sense that, with Cadence, you have to tell the contract exactly what it should be expecting. So this greeting variable that's going to store information wants to know what type of information it's going to be storing. In this case, we're telling it, okay, you're going to store a string. Now, a string is like characters or words or it's text. Like, hello there, like my name is Jacob, right? Or my favorite candy is I don't know, Kit Kat, or the letter A, right? It's any piece of text. Whereas if we were to change this to an integer or int, an int is something like 0 or 12 or negative whatever that number is, right? It's a number. Okay, so very different. So in this case, we're going to tell greeting, all right, you're going to store a string. So that's that. Now, one more concept we have to learn is that in contracts, when you put this contract out there into the world, all your variables, right? Again, variables, I'll type that here. Variables like this greeting thing below store data. So all the things in our contract that are going to store data, they need an initial default value so that when we put this contract out there into the world, it'll know what the initial value of this greeting is supposed to be. That way, if someone tries to read it, right, the contract will be like, okay, this was the initial value that the person gave it, and maybe they change it in the future, maybe they don't. That's up to the rules of the smart contract. But we have to give it a certain value. So what we're going to say is self.greeting equals hello there, Kelcoin. I just picked Kelcoin because he's in the chat. So that is what our initial greeting looks like. Now, self, I'll explain this in a second. So init, what the init function means, right? So what we did is we typed init, these two, parentheses right here, and then we opened up some brackets. What this means is this function, right? A function is something that runs or executes at a certain point in time. This init function executes when we click this deploy button. So contracts, right? A contract is only ever deployed one time. So when you put a contract out there, it's out there forever, forever. So this init function right here, that's what we call it, is only ever run one time. And when this is run, or when we click this deploy button, it's going to set self.greeting, and self is basically referring to the thing above it. So self is just saying, okay, pick this greeting right here. So self.greeting, and we're going to set it equal to hello there, Kelcoin. All right. So what I'm going to do is I'm going to go ahead and click redeploy here and confirm. So on the playground, it allows you to deploy things multiple times. But I just clicked, redeploy, and it deployed it right here. Okay. So, this should be pretty obvious. But what does everyone think the value of this greeting is right now? What is currently stored inside of this variable? And you can go ahead and type it in the chat so that I know that people are sort of understanding this. Yeah, exactly, Professor Meta, exactly. And I'm assuming that, other people would get this as well, that what's currently stored in there is hello there, Kelcoin, right? So why don't we go ahead and actually read this data? Shiver. Yeah, close. So we're going to go ahead and actually read this data. Now, based on what we covered in chapter 1, in order to read this data, should we call a transaction or should we call a script? I'm going to put two words in the chat, and I'm going to put a transaction and put a script. So thumbs up which one you think we should call. Great. It looks like everyone's understanding it. So we want to call a script. Great. Andrew and Griet, awesome. And everyone that thumbs up script, you're totally right. Because a script is something that reads from the blockchain where a transaction changes the blockchain. So let's go to the script and we want to read what this greeting is. We already know what it is, but let's just verify it for ourselves. So we click on script and it already populates some information here. So I'll explain what this means in a second. Actually, I'll explain it now. So what this does is it says, okay, public function main. Now, again, this is a function. This is something that runs when we tell it to run. So, and then everything that happens is inside these curly brackets. Now, what it's telling us, what this int means here, is that this function, right, that's going to execute some code returns an integer, okay? And in this case, it works because it returns 1. So return is the value we're giving back to the person. Now, in this case, the person is, us. It's you and me that are looking at what the value of this function is going to be. So when I click execute here, look at what it prints. It says, okay, it returned, the type of it is an integer, and the value is 1, right? Can you see that? And that's because the function here is telling us we're returning an integer, but the return value is 1. So what if I wanted to return, who else is here? Ashley. Hey, Ashley. Let's say I want to return Ashley, right? This error is saying, wait a minute. There's mismatched types. We're expecting an integer, right? You're telling us you're returning an integer, but you're actually returning a string. So how could we fix this function so that this works? Anyone have any guesses? And then we'll get to how we read our greeting variable. But how do we actually change this function so that this doesn't give us an error anymore? Yeah, so exactly. So Caliban says string, right? And I'm hoping that everyone got that as well. So the way to fix this is to change this to string. To say, okay, our function main is going to return a string, right? And that's actually what we're returning right here. So let's go ahead, clear this, and execute again. And perfect. We get string and Ashley. So now what we want to do is we want to figure out how to actually read the value of our greeting variable. So let's go into here. And what we're going to do is we're going to tell our script where to read this information from. The way to do that is say import. So import basically means we're bringing in some code. Import the hello world contract from, and then I have to put an address here, right? What address should I put here? What address is the hello world contract deployed to? Yep, exactly. OX01. So I put OX01 here because what this means is I'll put a little comment here. By the way, these little slashes mean this is a comment. So it's not actual code. It's like we can just write stuff here. This means, import means bring in some code. The second part, like hello world, is the contract name. And then from OX01 means this is the account hello world is deployed to. All right. And now once we do that, what we can do is say, okay, the value that we want to return is hello world dot greeting. So we're going to take our hello world contract and we're going to say dot greeting variable. So in other words, this means, return the greeting variable from our hello world contract. All right. So when we execute this, oh my God. Okay. Quick pause. So I do this speech every single boot camp, and the instructors are probably sick of it at this point. The playground is like extraordinarily bugged, and I've basically been in World War III with the playground since April of this year, and it literally battles me every single boot camp. But I have good news, and the good news is that actually should I don't think I don't think I can share that actually. Wait, I don't know if I'm supposed to share that, but you can imagine what the good news is. It's along the lines of what Meta typed in the chat. Yes. Um, all I can say is that the playground is being worked on and in a big way. So, round of applause for me. I think I won the war. In the sense that the flow team is finally investing big time in the playground. So hopefully, by the time the October boot camp comes around, we won't have to deal with this absolute crap. But we don't let anything defeat us. So what we're gonna do is we're gonna refresh the page and we're gonna go again because nothing stops Jacob Tucker during his demo except that. All right. So we're gonna go ahead and redeploy the contract just to try again. So we redeployed it, right? Go to our script, and we're now gonna try again. And like I was saying, nothing stops Jacob Tucker during the demo. And boom, it worked. So look at what was returned. It returned a hello there Kelcoin, right? Woohoo! Woohoo! Yeah, Franken. I love that, Franken. It's great. The memes we get from the playground are always so fun. Um, but yes, right? So we did it. So does this again, the coding doesn't have to make like it's fine if you don't understand pub, it's fine if you don't understand function, it's fine if you don't understand this weird stuff, but conceptually, is this making sense to people in the sense that you know that we have a contract, it's in this account, it has a greeting variable, that's a string type, that's important. We set it to we set it to this string, and then we use a script to read from it. And the way that we read from it is we tell the script what the contract is and where it is, and then we do hello world.greeting and make sure the return type is the type of this variable. So I'm going to put a thumbs up in the chat. And if you understand that stuff, then thumbs this up. And if you don't understand it, then thumbs this down. So do we have to initialize all variables? Yes, you have to initialize all your variables all the time. You can't ever not initialize a variable. Mm-hmm. All right, so it seems like everyone is understanding the content, which is such good news. That is such good news. So let me actually get back on track here. I think I pretty much covered everything in this day, right? Reading our greeting. Perfect. Okay, so we're on day 2 now, and this is the last day we're going to cover before we stop. So, yeah. Okay. So we just covered how to run a script. I'm now going to show you how to run a transaction. But really quick, let's look at this diagram really quick. And again, I am quite the artist, I have to admit. But this is what really is going on. So we have this person. For some reason this cracks me up every time I see it. But because when I drew this, I thought I was like so professional. Like every time I look at it now, I'm like, yo, what is going on here? But sorry. Um, I get easily distracted. But anyway, so this little smiley face is a person, right? And this person wants to modify or view the blockchain. So to modify the blockchain, they call it transaction, right? And the transaction, just like a script, is like the middle layer, right? It's something that sits in the middle between a person and a smart contract, where the transaction modifies the blockchain and the script views the blockchain. So The reason I put this diagram here is because sometimes in code, it gets confusing, like what this looks like. But if you're a visual learner, this is what's going on, right? There's a middle layer in between the person and the smart contract, and that's what transactions and scripts really are. Okay. Um, and we talked about the differences between these two already, so we're not going to really go into it. But this part can sort of help where a script, you see public function main, parentheses, a return type, and a return statement, right? That's kind of exactly what we see right here, right? Whereas a transaction, you'll see something where it says transaction and there's a prepare and an execute something. That's what this is. So that's what we're seeing right here. Okay. The transactions are pretty different. And again, we're going to walk through all this together, so don't worry. So we already called the script. Perfect. Now we want to change. Okay. So what we want to do is we want to call a transaction, and the end goal here, and then we'll end this workshop, is that we want to change this greeting. Now I want to ask all of you. I'm gonna put a question in the chat right now. Can we change the greeting variable? If you think we can, thumbs this up, and if you think we can't, thumbs this down. Ooh, I see the votes switched. The votes started out strong. Ooh, Shiver, you're ahead of the game. But the answer, actually, Shiver, you're right, but that's not quite the reason yet. But you are right though. Um, okay. So we have 10 votes no and 2 votes yes. So the reason, so the answer is no. So if you put no, you're correct. And there's 2 reasons for this. The first reason is because remember what I said about smart contracts. Smart contracts are actually really dumb. They don't know how to do anything unless you tell them what to do. In this case, we have not put any code that allows you to change greeting, right? This smart contract here doesn't define any code that could let us change the greeting. So the contract isn't able to change the greeting. So what we're going to do is, and Shiver, I'm going to come back to your point in a second here, but that was reason number 1. So in order to change the greeting, we have to tell the contract how to change the greeting. So we're going to make something called a function. Now, a function looks like this. In order to make a function, you have to type public, right? Pub means public, so this means anyone can call it. Function, and function is represented as fun, so fun for function. And then we give it a name, and we're going to call it change greeting, okay? Now, we put these 2 parentheses here. I'll explain why in a second. And then these brackets. So the actual, logic of this transaction, or sorry, the logic of this function call goes in here. So what I mean by that is sorry, um, I'll say, in other words, what we want to perform will go in here. Okay, so what actually happens will go in here. So Professor Meta says, can we think of a smart contract as an API? Exactly. Yep. So in the Web 2 world, that's exactly how you would think about it. Smart contracts are basically a backend. Yeah. So that exactly. Um, cool. But of course, the difference is that it's always public, it's always accessible, it's not centralized, right? So it's an API that is modified for the blockchain world. Yeah. Okay. So cool. So what we're going to do is we're going to set this greeting variable inside this function. We're going to set this greeting variable to a different value. So what we're going to say is self.greeting equals goodbye there. Or we're just going to say goodbye, frankincense. You stink. That's mean. You are loved. You are loved. Um, there we go. I loved a kid with participants, but anyways, yeah, you are loved. Okay, that's what we're gonna do. Now we're getting an error here, and this leads to our first sort of complicated coding thing. And we're gonna get to this. So again, this is mostly a conceptual workshop, so don't worry about the coding. But if you're curious, the reason why it's giving us an error here is because when you put this let keyword before a variable, let means you can't change it. So when we put let here, like we're not even allowed to make code to change it. It's not going to work. We have to put var. So var will allow us to write code that changes this variable. Okay. So there you go. All right. So I'm going to get rid of the comments here so that it looks less complicated, right? It's pretty simple. So we're going to go ahead and redeploy this contract. All right. Now, we want to be able to call this change greeting function that will change the greeting from hello there, Calcoin, to goodbye, frankincense, you are loved. So let's go to a script. And when we call the script right now, it says hello there, Calcoin, right? Because when we redeploy this contract, it set greeting to this value. But now we want to modify the blockchain to say, okay, the greeting variable is now this. So in the chat, should we call a transaction or should we call a script? Any guesses here? Nice, Christina. Exactly. So we call a transaction because we're modifying the state of the blockchain. So let's go inside of a transaction. Let's delete some code here. And here is a basic transaction that does nothing. Okay, so this transaction doesn't do anything. Now, I'm going to ask you that until we get to like chapter 3 or even 4, completely ignore this. So don't even pay attention. So don't even pay attention to prepare stage. So this is the prepare stage, and this is what we call the execute stage. Don't even pay attention to them, or don't pay attention to this, but pay attention to this part. So execute is where we actually want to perform, something. We want to do something in our transaction. So what we're going to do is we're going to attempt to call this function. But what do we have to do first, right? Remember in this script, we wanted to access this greeting variable, but we had to tell our script what contract to even look at, right? We want to do that in the transaction. So what should we add up here in order to tell our transaction to do something for this specific contract? What do we have to do at the top here? Import, exactly. So we have to import hello world from OXO1 so that down here in the execute stage, we can say hello world dot change greeting. Oh God. Playground. Let's try and refresh the page. All right, boom, there we go. So this is how you call a function. You say hello world dot change greeting, and you put these two parentheses here. This means we're calling a function, all right? So let's go down here. Let's go to our script really quickly, and let's just make sure that it still says hello there, Calcoin, all right? We're gonna go to our transaction now, and we're gonna run this transaction. Now, right now, ignore this. You can pick any account you want. So it doesn't matter who you pick here. But we're gonna pick account, let's just pick account 4, because why not? So let's send it. Oh my God. Let me, the playground is being buggy. Hold on one sec. Okay, let's try and send it. Uh, why do you do this to me, playground? Please. I'm putting a prayer in the chat. Sometimes this works if I put a prayer in the chat. Yep, told you it worked. So when I put a prayer in Discord, it always answers my call. I don't know why. But love that. So, anyways, um, you see we got no errors. So it went through. So if we scroll down to the script and click execute, look at that. Boom. It changed to goodbye, frankincense, you are loved. Woohoo. Right? I'm raising my hands right now. I'm celebrating my computer. Let's go. We ran our first script and our first transaction. Woohoo, right? We're legends. We're Cadence legends. So I'm not trying to, boost your ego. Of course, all of you will never get as good as me. I think we all know that, right? All of you will never be as good as Cadence developers as I am. That being said, you're already, I would argue, The top 0.01% of cadence developers in the world already. Probably 0.000001. And that is something to be proud of right there. So if Professor Meta says, can you send a value to change the data stored on the blockchain? And Professor Meta, I swear you read my mind, because that's what we're going to talk about last. So this is our last little topic here. So right now, right, there's a bit of a problem with this function, right? The problem is that what if we wanted to change the greeting to goodbye frankincense, you stink, right? Of course, no one would ever say that, but what if we wanted to, right? We can't, right? And we technically could by changing this and redeploying the contract. But I want you to remember that this is a testing playground. This isn't the real world. In the real world, you would never ever redeploy your contract, right? Once you deploy your contract, you can't redeploy it. So this isn't possible. So in the real world, your contract would look like this, and you would go to change it, but you couldn't, right? You would have to maybe even make another function that says change greeting to, and in here you say you stink, and then you would have to call this function, but then you would have to update your contract of a new function. It's terrible, right? You don't want to do that. The way to do that is what you do instead is you pass in a new greeting variable that is a string. And instead of setting it to this, you set it to new greeting. Okay, so this is a bit confusing, but basically what we just did is we say, you know what, instead of setting greeting equal to hello frankincense, you are loved, we're going to set it to another variable that gets sent into this function that is also a string. Remember, this can't be an integer, because then it's going to say, wait a minute, you're trying to set a string equal to an integer, which doesn't work, right? It has to be the same type. So we're going to redeploy this contract. Okay, go back to our transaction, and now if we refresh this page, it should give us an error. Yep, it gives us an error now. We have to actually pass in a value into this function. Okay, so what we're going to do is say, you know what, new greeting. Remember right here, we called this new greeting, and it's a string type. Okay, new greeting is a string type. We're going to pass in new greeting, and the value is going to be I love uh let's say, who else is in here? Um okay, Griot, right? There we go. I love, am I pronouncing that right? Griot? Griot? I love Griot, okay? So what's going to happen is if we go ahead and run this transaction, send it, okay? No errors. Let's go to our script and execute. It says I love, oh, Gree. The playground bugged, so the O and T got cut out of your name, Griot. Oops. Thank the playground, not me. So I love Gree. That's the new name. I love Gree. But if we go back, let's change this to I love Professor Meta. And let's send this one. Send. And go back to our script. And now it says I love Professor Met. So there you are, you're Professor Met. You're Professor Met. So you can see that the benefit of doing it this way is that we don't ever have to change this code, but we can change it in our transaction to send in whatever data we want. So Professor Meta says, is new greeting a variable? Yes. If we go by the definition that variables store data, right, new greeting is in fact a variable because it's storing the new value right inside of it. So yes, that is true. Okay. And we're out of time, so I'm going to take 1 or 2 more minutes. I promise we're almost done. But you can actually take this one step further. And the real way you would actually do this is because, again, in the real world, you never change contract code. So you have to do it this way. In transaction code, technically, you could do it this way, where you keep changing this. But you don't really want to change transaction code because it's really nice if you have one transaction that takes in data from a different source. So what we want to do actually is up here, say new greeting string, and then have this be new greeting. And now we can type it into here. So this typed, actually, maybe it makes more sense if I say user input and then put user input right here. So what's going to happen is it's going to say, okay, user input, right? I'm going to type a value in here like cookies. right? And it's going to take cookies, bring it here, right? So now cookies is in user input. Then it's going to bring that down to here and pass user input, which is cookies, into new greeting. And then that's going to get passed into right here. And then we're going to set greeting equal to new greeting, which should hold cookies. So if I go here and type in cookies and send it, go down here to the script and click execute, we see cookies. So this way, we don't even have to change transaction code. We can just input it however we want right here. So I hope that makes even a little bit of sense. But that is what, that's how you input data into a transaction. And the same thing, by the way, goes for scripts. So if we wanted to, we could put user input here, and let's just say this is an integer, and we want to return an integer. And maybe what we want this script to do is we want to take the user input and we want to add 1 to it. So what we're going to do is we're going to type in 1, and it should give us back 2, right? It's going to take in the user input, do 1 plus 1 equals 2, and return an integer. We execute, it gives us 2, right? So there we go. So that's all I have for today. Sorry that we went overtime. I really hope that gives you, first, basically this lesson was supposed to give you interest in Cadence and generate some excitement for it. So if anything, even if you're lost in the coding, I really hope that you're at least more interested in learning Cadence. And if you are, I will see you on, when is our next one? Sunday? Uh, I will see you Sunday at 1 p.m. Eastern. All right. So also for all of you that came, we have a float for all of you in the chat. The float is the password is workshop1, just like this, workshop1. So go ahead and claim that, and that will be your float for coming to this workshop. Thanks everybody. I hope you found that helpful. And on Friday, or sorry, on Sunday, we're gonna start coding a lot more. All right. If you have any questions, go ahead and ask in the chat channel. And also remember to submit your quests and also the quizzes, and we will review those for you. Yeah. Also, we have our town hall on Sunday at 11 a.m. EST. So make sure to come to that town hall if you want to learn more about Emerald Academy, Emerald City, all the products we're building. That's a great place to learn more. All right. I hope you're doing well, Ashley. It's so good to see you here. Thanks for tuning in. Bye, Ash. Bye, everybody.